Hello, my dear students. It's my pleasure to meet you today. I am here to discuss with you some geometrical lessons, which is following applications and operations on vectors. Some students see that these questions or lessons are difficult, but inshallah will be clear and will be easy. So look with me. We discussed before about the triangle of vectors. If we have a triangle here, ABC, and we have the vector AB, vector BC, and to find the sum of AB plus BC, we wrote that AB plus the vector BC. Yes, pupils who students who remember say it will be, of course, AC. So the vector AB plus the vector AC equals the vector AC. And if someone asks me about this question, if we have a triangle here, ABC also, what happened if we have a vector AB plus another vector BC plus the third vector and have the same direction CA? What about AB plus BC plus the vector CA? What's the result? Look carefully at this triangle and this one. We have said before that AB plus BC equals AC. So we can substitute instead of AB and BC by the vector AC. So we have now the vector AC plus the vector CA equals what? These two vectors. Of course, this vector equal negative this vector. So the vector AC equals negative the vector AC. This CA, we can change the starting point with the end point and put negative because the direction will change, will be opposite. So the answer will be 0 vector. So we can say that the vector AB plus the vector BC plus the vector CA equals 0 vector. We will have some examples here. Yes. The first example, if we have a quad here, ABCD is a quad. Any quad, A, B, C, D is a quad, and the question is prove that number 1, the vector AB plus the vector BC plus the vector CD equals the vector AD. Where is AB? AB here, have the same direction, this direction from A to B. BC is this one, and CD is this one, and the request is to prove that AB plus BC plus CD, okay, AB here, sorry, start from A to B, AB plus BC plus CD. We want to prove it, all of these, the sum of all of these vectors equals the vector AD. It's easy to complete the triangle here to get the triangular vector, and of course AB plus BC, the vector AB plus the vector BC, of course will be equal the vector AC. Okay, so we can substitute by this expression AB plus BC by the vector AC. So we can put the vector AC here instead of AB plus BC related to this triangle, plus the vector CD. It will be equal what? AC plus CD by use the triangle vector here, of course, equals AD. So we now prove this question. We have another question here. Say that, prove that AC, the vector AC, minus another vector BC equals the vector AD minus the vector BD. We know that here AC minus BC, if we substitute by AC by two vectors, where is AC? AC here equals AB plus BC. So we can substitute by AB plus BC instead of AC. So instead of AC we write AB, the vector AB plus the vector BC, and we put minus the vector BC itself as it is, and we have also AD, the vector AD in this triangle. We can substitute instead of it AC plus CD, AC plus CD, AC plus CD instead of the vector AD here. So we substitute, but we put BD as it is. What is happening now? We have BC, the vector BC minus the vector BC, you can cancel them, equals 0 vector. And this side also, we have the vector AD equals AC plus CD. Okay. Or we can put instead of AD as this, instead of AD equal AB plus BD. Okay, AB plus BD, and we will put BD as it is. So we can cancel the vector BD with the vector BD, and the answer will be only the vector AB. We have here the vector AB, only vector AB on the left side, and we have the same vector on the right side here. So we have proved that the left hand side equals the right hand side. Okay, so we have proved that AC minus BC vectors equals the vector AD minus BD, and we have proved this question also. Okay, my dear students, proofs here, it seems difficult, but you will try, and I can solve it by a method, and you can solve it by another method. So let's have some other example here. If we have another quad A, B, C, D like that, A, B, C, D is a quad, and we have AC and BD are the two diagonals here. Okay, and we have a relation here between BC, the vector 2 twice the vector BC equals 3 the vectors AD. So we have a relation here between BC and AD, and the request is to prove that A, B, C, D is a trapezium or a trapezoid. To prove that A, B, C, D is trapezium, we have to prove that any two opposite sides are parallel but not equal. We have here twice BC equals 3 AD. We can write it by this method. We can put 3 over 2 AD. So we have here the vector BC, this vector, equals 3 over 2 the vector AD. When a vector equal a real number multiplied another vector, so these two line segments will be parallel, or these vectors will be parallel. So we have proved that AD parallel to BC, and because BC doesn't equal AD but equal a real number multiplied AD, so BC here doesn't equal AD as a length. Look carefully at these line segments here. We try to say that line segment BC here parallel to the line segment AD, and the line segment BC doesn't equal in length the line segment AD, so we don't put any ray or line segment or even vector. So we have here two opposite sides are parallel but are not equal in magnitude or doesn't equal in length. So we have proved that ABCD here is a trapezium. The next request is to prove that the vector AC plus the vector BD equals 5 over 2 the vector AD. Look carefully at this drawing here. We have a quad and we have AD here. We have AC also and BD. We will try to change AC and BD by vectors gives something related with AC. And don't forget that BC here or BC here equals 3 over 2 AD. So AC here equals AB plus BC. So we can replace AC by AB plus BC. The vector AB plus the vector BC. And we can replace the vector BD here by the vector BA plus AD. BA plus AD. Okay? We have here the vector AB and vector BA, their sum equals 0 because they are opposite vectors and equal in magnitude. We have also BC vector, and we know BC equals 3 over 2 the vector AT. So we can replace the vector BC here by the number 3 over 2 AD plus AD itself, which is we can write it equals 2 over 2 AD, or we can add 3 over 2 plus 1. 3 over 2 plus 1 equals 3 over 2 over 2 over 2. So we can add them. 3 over 2 plus 2 over 2 equals 5 over 2 AD. And this is the right hand side, and we have proved that AC plus BD equal 5 over 2 AD. And my dear students, we have many questions for you to explain, and you have solved many questions from these examples to have the experience to act with any proof or any example. So we can concentrate with me. The question is, if we have a parallelogram like this, This diagram is A, B, C, D. And my dear students, try to concentrate with the name of the parallelogram. Parallelogram, if we start from A here and you go to B to C, say A, B, C, D, and don't say A, B, C, D. Some students make it as a fault, say A, B, C, D. No, you have to, you must made it as a circular way, A, B, C, D from outside. So we have a parallelogram here, A, B, C, D, and we have also CA and BD and intersect at M. They are diagonals, and we have M is a point in the plane of the parallelogram, and we can say N here. We have ND and NC, NA, NB, and finally NM. You know the request is to prove that the vector NC plus the vector NB plus the vector NA plus the vector ND, all these vectors from N, NC plus NB plus NA plus ND equals 4 times the vector NM. And we know that the diagonals here of the parallelogram are bisecting each other. So this part, which is CM, equals this part MA, and this part, which is BM, equal also this part, which is MD. Okay, and we will try to choose triangles have these halves of diagonals. So we will choose a triangle NCM. What is this triangle? NCM here, we can say that NC, the vector NC, plus the vector CM, of course it will be equal the vector NM. So the vector NC plus the vector CM equals the vector NM, and will be the first equation here. And we will choose another triangle which is NBM. What in the triangle NBM? We will find that the vector NB plus the vector BM equals the same vector NM. And this is the equation number 2. And we will choose another triangle NDM. Why NDM? Because we will have DM also. So by choosing triangle NDM, we will have ND plus DB, DM, ND plus the vector DM equals the vector NM. And this is the equation number 3. We will choose also the last or the final triangle, which is NMA. In triangle NMA, we will find that the vector NA plus the vector AM plus AM equal the vector NM also. And this is triangle number 4. It seems to you that it's very big question and very big answer, but my dear students, it's very clear and very small, very easy question. Why? Because forget the drawing here and put and pay attention to these equations. We have nm plus nm plus nm plus nm will get 4 nm, and so from 1, 2, 3 and 4 equations, by adding, it's easy to deduce that here we have nm plus nm plus nm plus nm, it's 4 nm. This is the right side. Look carefully at left side. We search about cm and am. We have cm here and am here, cancelled with each other because they are equal in magnitude but opposite in direction. Search also for bm and dm. bm here and dm here, we will cancel because they have the same magnitude and opposite direction, so are equal. So one of them equal negative the other, so the sum equals 0. And the remainder here is nc, the vector nc, plus the vector nb, plus the vector nd, plus the last vector na. Okay, look carefully at this and at this. This is a request here to prove that all these na and the vector nc plus the vector nb plus the vector ndna plus the vector nd equal 4 times the vector nm, and we have this proof now. So now it's very easy for you, but you have to solve it again with yourself, and inshallah will be easy for you. My dear students, it's vectors. It seems difficult for the first time, but when you try to act with it carefully and slowly, don't be in rush, but you will imitate it. You will find it very easy. And we have another example here for the triangle. So concentrate with me. If we have a triangle here like that, this triangle called ABC, and we have D as a midpoint here, and we have AD is a median. D is a midpoint, so AD is a median from the previous studying. And the request to prove that the vector AB plus the vector AC equals double the vector AD. So we have a vector and another vector, and the vector which is the median of this triangle. Okay, we will get this from the two triangles, this one and this one. By imitating in the triangle ABD here, we can say AB plus BD, triangle here, triangle ABD, will give us that AB plus BD, the vector AB, plus the vector BD equals, of course, the vector AD from the triangular vector rule. And this is the equation number 1. We can use the other triangle here, ADC, and we will have the vector AC plus the vector CD, of course, equal the vector AD. Look at the right side. We have AD here and another vector AD here. So from 1 and 2 equation, by adding, we'll get what? We will get on the right side AD plus AD. So it's double the vector AD. And look carefully to the left hand side. We have the vector AB. Okay, the vector AB plus we have the vector AC also. What else? We have vector BD. Look carefully at BD and the vector CD. They are two vectors opposite in direction and equal magnitude, so we can cancel them because one of them equal negative the other. So we can cancel them. So the answer, the final answer will be the vector AB plus the vector AC equal double the vector AD. Okay, this is the final equation. So my dear students, we have a very benefit from the triangle and median, and we have also parallelogram. If we imitate about this parallelogram here, so look carefully with me and pay attention. If we have A, B, C, D here, this is the parallelogram, and we have AC. AC is the diagonal of parallelogram, and we have a vector AB and another vector ED. The rule is the vector AB in the parallelogram plus the vector AD equal the vector AC, which is get out or exit from the same point, which is the diagonal of parallelogram, equals the vector AC. And if we try to prove it, it's very easy for us because we know that each two opposite sides in parallelogram are equal in magnitude. So the vector AD here, of course, will be equal to the vector BC. And if we concentrate here in this triangle ABC, we will find easily that AB here, the vector AB plus the vector BC equal the vector AC from the triangular vector rule. And we know that BC here equal in magnitude and direction the vector AD. So we can cancel this BC vector and put instead of them the vector AD. So the vector AB plus the vector AD, of course, equal the vector AC. This is the important rule for parallelogram. Okay, we have another example for you. If we have a quad and we would like to prove this quad is a parallelogram, it's just to prove that two vectors have the same direction and same magnitude. If we have two opposite vectors are equal in magnitude like this and equal in direction like this, so it will be a parallelogram. But the other question is, if you want to prove that a quad is a rectangle, so we have also proved that this quad first is a parallelogram, and we will take some property from rectangle as a right angle here. If we prove that this is a right angle, it will be a rectangle. So look carefully at this example here. We have ABCD here is a quad, and the request is to prove that this quad is a rectangle, and we have the points in lattice or coordinates The point A will be 2 and negative 2. The point B will be 4 and negative 2. The point C will be 2 and 3. And finally the point D is what? Okay, 0 and 3. Sorry, this example just to prove that this figure or this quad is a parallelogram. So it's enough for this question that proves that A, B, C, D is a parallelogram. Here A, B, C, D is a quad, and we would like to prove that A, B, C, D is a parallelogram. We just say that the vector AB equals the vector B minus the vector A. B minus A here will be 4 and negative 2 minus A, which is 2 and negative 2. And 4 minus 2 will be 2. Negative 2 minus negative 2 will be 0. Okay, 4 minus 2 equals 2. Negative 2 minus negative 2, because minus negative is positive, so it's positive 2. 2 minus 2 plus negative 2 plus 2 equals 0. And we have also DC. The vector DC here will put the vector C minus the vector D. The vector C here will be 2 and 3 minus the vector D, which is 0 and 3. 2 minus 0, it's 2. 3 minus 3 is 0. Look carefully, my dear students, to this. We have now the vector AB equal 2 and 0, and the vector DC are 2 and 0 also. So we have deduced that the vector AB exactly equal the vector DC. The vector AB equal the vector DC. So AB itself parallel now to DC, and AB as a magnitude or length equal DC. So ABCD now is a parallelogram. Therefore, this quad is a parallelogram. Okay. Some questions comes, and sometimes it requires to find the last point. And if we have a parallelogram here like that, if we have a parallelogram like that, A, B, C, D, and we have the 3 points, A, its coordinates will be 2 and negative 2, and B have coordinates 4 and negative 2. C coordinates 2 and 3, and D has not a coordinates, and the request is to find the coordinates of D, which is X and Y. Okay, and this is a parallelogram. If we have this ABCD is a parallelogram, so of course AB equals the vector AB equal vector DC, and of course the vector B minus A equals the vector C minus D, and of course the vector B minus A equal 2 and 0, and the vector C minus D equals 2 and 0. C here is 2 and 3 minus D, which is X and Y. 2 and 0 here equals 2 minus X and 3 minus Y. By solving these equations, we have here 2 minus X equal 2. We'll easily find out that X equals 2. And by solving this equation also 3 minus y equals 0, we will find that y equals 0. So the point D will be 2 and 0. 2 and 0 for D. Okay, my dear students, let us take some break and we will return again. Don't go away. Again, my dear students, hello. We will return to our discussion here now. We have an example here. We have A, B, C, D is a quad. And we would like to prove that this quad is a rectangle. This quad have A, the point A here, will be 0 and 1. The point B, 4 and 5. The point C will be 1 and 8. And finally, the point D is -3 and 4. Okay, here is the points. To prove that A, B, C, D, the quad A, B, C, D is a rectangle, we must prove first that this rectangle, this quad is a parallelogram. And if we have a quad like this, A, B, C, D now, so to prove that this quad is a parallelogram, first we have to prove that the vector AB equal DC or the vector DA equal the vector CB. So we will choose the vector AB. The vector AB will be vector B minus A. B is 4 and 5 from this, and A is 0 and 1. And of course, the answer will be 4 minus 0 equal 4, and 5 minus 1 equal 4 also. And we will try to find out the vector DC. The vector DC will be the vector C minus D. Concentrate or pay attention about C minus D. We start from DC here, and when we make the minus or subtraction, we start with C minus D. So C equals 1 and 8 minus D, which is -3 and 4. 1 minus -3 is 4, and 8 minus 4, it also equals 4. And we have now AB 4 and 4, and also DC 4 and 4. So AB as a vector equal the vector DC. Therefore, the quad ABCD is now a parallelogram. And we know that to prove that a rectangle is to prove that we have a right angle here. And if we have a right angle, the parallelogram will be rectangle. So we'll try to find out the vector CB. The vector CB equals B minus C. B equals 4 and 5 minus C, which is 1 and 8. 4 minus 1 equals 3, and 5 minus 8 equals -3. Look carefully, my dear students, to the vector CB, 3 and -3, and the vector DC, which is 4 and 4. To prove that this angle is right, we have to find the slope of DC and the slope of AB of CB. Okay, the slope of DC equals y over x equal 4 over 4. The slope, which is m1 of DC, equals y over x, which is 4 over 4 equals 1. and the other slope of the vector CB here is y over x, which is equal negative 3 over 3, which is negative 1. And we have known before that we have, if we have m1 multiply m2 equals negative 1, so the straight line or the vector m1 will perpendicular to the vector m2. And we have the first one equal 1 and second equal negative 1. The answer is negative 1. So the vector DC here is perpendicular to the vector of CB. So this angle is right angle. So the quad ABCD now is a rectangle, because we have proved first as a parallelogram and we have a right angle here, so it's a rectangle. Okay, my dear students, we can prove many things here. As example, we can prove a quad as a rhombus. What we need to prove that a quad is a rhombus? First, we have to prove, or we must to prove it as a parallelogram. Then we will prove that the two diagonals, as example, are perpendicular. So we have example here. If we have a quad ABCD, and this quad have points A, B, C, and D. We have A here, 5 and 3, B, 3 and negative 2, C, negative 2 and negative 4, and finally D is 0 and 1. And we want to prove that the quad is a rhombus. As we agreed before, that to prove that a quad A, B, C, D is a rhombus, we have to prove the first that it is a parallelogram. So we will prove that AB equal DC or BC equal AD. We will choose AB, the vector AB here equals the vector B minus vector A equals B minus A here equal 3 minus 5 equal negative 2. Negative 2 minus 3 equal negative 5. So it's negative 2 and negative 5. And the vector DC, which is C minus D, C minus D, C here equal negative 2 minus 0 equal negative 2 also, and negative 4 minus 1 equal negative 5. And we have succeeded to prove that the vector AB now equal the vector DC. So the quad now is a parallelogram. To prove that the parallelogram now is a rhombus, we have to prove that the two diagonals, like that, as is perpendicular. So we will find the vector AC equals C minus A, C minus A, negative 2 minus 5 equals negative 7, negative 4 minus 3 equal negative 7 also. And we will find also the vector BD. The vector BD minus D minus B, it's D minus B. 0 minus 3 equal negative 3, and 1 minus negative 2 equals 3. And the slope of this one equal y over x, which is negative 7 over negative 7, which is 1. And this slope for this vector equals y over x, which is 3 over negative 3, equals negative 1. So when we multiply m1 multiplied by m2 equals 1 multiply negative 1, so it's negative 1. So easily we can deduce that the vector AC is perpendicular to the vector BD. The vector C AC here now is perpendicular to the vector BD in the program ABCD. So the program ABCD now is a rhombus. Now it's easy for you to use that. We have proved that just a quad. We proved that this quad is a program first, and we find out the two diagonals, and we proved them that they are perpendicular. So it's a rhombus. Okay, my dear students, we have now a question about triangle. I think it's now easy for you to prove that a triangle is right angle triangle at any vector, any vertex. So we have a triangle here, ABC, and we have A, okay, A equals 3 and 2, and B 2 and negative 1, and finally C negative 4 and 1. And the request is to prove that the triangle ABC is a right angle triangle at B. And the second request is to find its area. It's easy for you that find the solution is we have to find the vector AB and BC. The vector AB now is B minus A, B here 2 minus 3 equal negative 1, negative 1 minus 2 equal negative 3, and the vector BC, the vector BC is C minus B. C minus B will be negative 4 minus 2 equal negative 6, and 1 minus negative 1 equals 2. And we will find the slope of the first, which is AB. The slope of the first is y over 1, y over x, which is negative 3 over negative 1, which is 3. The slope of the second will be 2 over negative 6, which is negative 1 over 3. And by multiplying m1 times m2, 3 times 1, negative 1 over 3, the answer will be negative 1. So these two vectors AB perpendicular to BC. So now we have a right angle triangle. And you know that the area of the triangle equals half base times height. Area half times base times height. Which is base? Base is BC and height is AB. And we must find or calculate the magnitude of BC and BA. We have here the AB. To find the magnitude or the length of the vector AB, we have to find the norm of AB. The norm of AB equals negative 1 power 2 plus negative 3 power 2, which is equals 2. And to find out the length of the vector BC here, which is the base, equals square root also BC here equals negative 6 and 2, negative 6 power 2 plus 2 power 2. We have here 2 power 2 equals 4 and 6 power 2 equal 36, and the answer will be root 40, square root 40. We have here the answer of the norm of AB equals square root 10. Length unit, and this is length unit also. Okay, so to find the area, multiply half times the base, which is CB equal square root 40, multiply the height, which is AB, which is square root 10. So the final answer will be 10 square unit. Okay, it's a very easy and enjoyable example, my dear students, and by this question we can end this episode to you. Thank you very much. Be happy and try to study hard, and we will return again next Friday inshallah to study the applications on vectors. Goodbye and good luck.